So it's great to be here today to see everyone. Like, so happy to be here. Um, so my name is Bunmi Akinremi, um, and I currently work as a machine learning engineer at Coachava, and Coachava is an advertising marketing company, right? Okay. Um, Next slide, please. So, uh, there's nothing really much interesting here, just particular about AI and ML, more into research engineering, and of course, I'm looking to publish some research papers, and I've grown interest in AI policy and economics. Weird. And so, outside tech, I write poems and probably take pictures, and I read a lot. Yeah. Okay. So before I start my session, so this was in Ghana. Um, Myself and my friends, we decided to go to the beach. Woke up early in the morning. We had a scheduled visit to Google office in Ghana, and we're like, we're so excited, dressed corporate, looking good, looking sharp, and just as we're about to book the boat ride, right? So the guy sent me a message and said he's sick. We would have to reschedule. Like, God, that's why I missed that opportunity. So like, what should we do with this free time, right? Let's go to the beach. The sun was out, seemingly sunny day, and we took boat to the beach. On the way, when we were almost at the beach, that's how this rain started. God. I was thinking maybe it's just, little. It felt so heavy that we came out of the boat. We had to stay like in a shade for about 1 hour before the rain now subsided. So when the rain subsided, this was how the beach looked like. Like, see the water, everyone is close. It was just a bad day. Like, it was just a very bad day. And what I now thought, like, we could have just checked the weather forecast. Like you could have just checked whether it was going to rain or not, because it's not a good idea to, go to the beach on a rainy day. And next slide. So yeah, I hope you laughed. I know I'm not good at jokes. uh, so quickly, I'll just introduce you to what forecasting is if you don't know what it is. And why forecasting is an art. To me, I find it really fascinating because I do a lot of social experiments, and I'm always fascinated every time at the result. So, um, and I also talk a bit about forecasting as a science, which I think a number of us are familiar with, and why it's important, some current challenges, and we just have like an interactive session. We'd have this case study interactive session, right? And yeah. So what is forecasting? Who wants to like just try like, okay?
Okay, for me, forecasting is like you're predicting something that has not happened, but you put one plus one together and you're saying, okay, this thing will happen. That's what forecasting means.
That's a nice try. Who wants to? Okay.
Yeah, thank you. I think forecasting is trying to predict the outcome of something based on what has happened before, using some statistical data to um, project what will happen in the future.
Those are two really good tries. Don't worry, I'll still ask more questions. Like, I don't know what else to say. Yeah, just like has it said and she has said, right? You're trying to predict what will happen based on what you already have or what you already know, right? And forecasting has, like, you can just divide it into two categories, right? There is a quantitative and qualitative. So quantitative is what somebody will just think of, right? Forecasting, time series analysis, right? You want to just throw data and then generate these random numbers and all. But then there is also the qualitative part, which I think that people don't really talk about. And that's the part where you're putting your human intuition, you're putting your experience, you're putting your familiarity with the concept, the business idea, the business use case you want to solve. And this is what most of my talk would be about. And quantitative is, yeah, time series, right? You have your numeric data, you have your trend, you're trying to predict what the stocks would be for the next 3 weeks, next 2 months, next 2 years, right? And, building models, using statistical models to see what this looks like. Okay. I can relate to this. Next slide. Okay. So why is forecasting an art, right? Um, I came across this LinkedIn post by Kate Whitehead, and she was just talking about who business forecasters are. And for me, I would say it's based on your intuition, knowledge of subject matter experts, broad tactics. That is, for forecasting, you have like various things. You have uncertainty, things that you can't model. You can't convert to numerical data. You can't make a data set out of it. You just know it, right? Your feeling, your gut. And even other human factors. Because, for example, if a company is trying to predict whether, if they release a new type of shoe, would people like it? Would students want to wear it? Is it fashionable? How much sales would they make? All those kind of things. Different things can happen. Maybe on the day they launched it, right? A scandal was probably exposed. Maybe they forecasted that they are going to make so much money, and maybe something terrible like Moped's death or something. It will just drop down their prediction. Like they already predicted that when this thing come out, people are going to buy it. But something happened that they can't control, and that affected their sales and all the kind of stuff. Right. Okay. Focusing as a science. Does anyone want to give me a try of what you think forecasting as a science means? Okay.
So, because you have said, we've agreed that forecasting is gathering information based on past and present events to say what would happen in the future. So, forecasting as a science now means organizing this data where you won't necessarily need human inputs, basically, the way you get in the data, the structure of the data, how it goes out, etc. All of that put together brings the idea of forecasting as a science. Sorry.
That was a good try. Let me see. Okay. Please, next slide. This was me, like, I want to do time series analysis. Facebook profit, like your first go to, and then I remember my first tax in my new role, and I just went on, created statistical distributions. Boom! Oh, I was having MAP of I think 2 point something. Yes, I got it. And I went to meet my boss, and the man just looked at me. Okay, Bunmi, can you translate this to business part of things, right? And then we sat down, we took the results, and then evaluated it, right? And then, just like the model was saying, I'm predicting that this company should spend $1 million, right? and you get $1 million back. That was the prediction. But in reality, based on what has happened, maybe the company spent like $400,000 and the company got like $200,000 as revenue. So you're now saying if I put $1 million, I'm going to get $1 million back. Like, how does that correlate, right? And this was why it was wrong, right? After we measured it against certain qualitative factors, we saw that it was just not possible, right? Next slide. And now forecasting as a science is typical forecasting that, no, right? It's numerical. You use either simple models like RIMA or highly sophisticated algorithms like Prophet, deep learning models, blah blah. And it also has different parts. So forecasting is not just time series. You have simulations, right? Where you're trying to see measure control variables. So if I put this, what is it going to be? Simulating like an environment, right? And then there's causality, which I'm really big on, right? And that is trying to see if how does this factor cause another thing, like cause this result? Does it directly affect, right? Econometric models and all. And for forecasting as a science, that's where you usually use data. But then for forecasting as an art, right, you're more about intuition. What do you know? What's your gut? What's your experience like? How have you been dealing with this kind of problem? Right. Okay. Now, you're a data scientist or a data analyst. How does this affect you, right? What importance? Why do you need to even consider the art of forecasting? That's because uncertainties. You see, when I used to learn about uncertainties, I used to think maybe it's just, yeah, I don't know, fear of the unknown, right? But you see, uncertainties can actually be big for you, like can be good for you and can be bad for you, right? So you have to factor in this uncertainty, right? And many times it comes due to human behavior, right? I've had to conduct some experiments where I try to monitor how humans react to certain situations. And what I realized is that you have different results for different times, right? Although there is a control variable where like, okay, this is neutral and then these are my test experiments. But then, uncertainty is, this person might have wanted to select this product, but maybe the person had a fight with his wife. And remember that his wife wore that clothes. I'm not buying it. He moves to the next one. Things happen and these are uncertainties that we somehow try to capture, but we definitely cannot capture everything, right? And you have misinterpretation and model validation, just like I explained earlier, where I got very good accuracy, but then it was totally wrong. Insights from unquantifiable factors, that is from subject matter experts, right? You're trying to build for health tech, and then you don't even have any healthcare person in your team, and you feel like because the model says it's 99.9% sure, therefore it is right. That is wrong, right? You need to put in these unquantifiable factors. What has the field been like, right? What has they tried on? What is working? What has not worked? What cannot work, right? And look at interpretability and explainability, right? Your model must be explainable rather, right? So your X, your Y, your exogenous, your endogenous variables, everything must make sense, right? Although we're looking at, I think that's one of the downside of overly complex models, right? You're trying to find a balance between interpreting and explainability. And that's why I'm also big on distribution models too, right? Okay. Sorry, like previous slides. Ethical and cultural considerations, probably something you want to look at. You want to build for a certain people. I don't even care how they might see it, right? You don't care how they might feel your product, what they think about your product. For even simple things as colors, right? Your brand color, right? Imagine if you're doing something and maybe you're using red. I know Yoruba people, right? Yoruba and red, they have this attachment, so you have to factor these things into it. And then root cause analysis, where you're trying to find what caused this, why, answer the right question. And that's why you need the art of forecasting. Of course. Of course, right. Um, your accuracy versus its real world meaning, right? Your good accuracy doesn't mean it's necessarily good. I think that's why it's a bit complex, right? If I have good accuracy, but yet that doesn't mean that my model is right. So what is right? That's why you need that art. Very, very important. And then there can be unforeseen events, things that you can't control. There can be a thunderstorm. I was listening to a podcast and about this nuclear reactor in Japan, and you know they built it in a very they use really good equipment, right, to make sure that it is resistant to earthquakes. But what they didn't realize, yes, it is resistant to earthquakes, but then they didn't factor in the fact that the sea is close by, and when there is a tsunami, right, it can affect that. And that was how they almost blew up Japan, right, due to the nuclear reactor overheating. And these are just unforeseen things. They probably built like, yes, no matter how big the earthquake is, except the earthquake is directly under it, it should not affect. But then unforeseen events, right? Issues with your data, right? How does your data come in? How does it go out? What format do you have to? Do you need to build pipelines? All those kind of questions. Then your model complexity. Do you need more complex model? Can you model simpler models? Do you need what kind of distributions and all those kind of questions? And then ethical concerns, data privacy, right? How are you making sure that you're not being biased? And those kind of questions. Okay. Um. So this is supposed to be a case study, right? We're going to model. It's a non-existent company, right? I just formed the name. Yeah. So Tech Future, they're a smartphone company, right? They want to launch their smartphone. They're like, okay, let's predict. How will our sales be, right? We want to optimize production, distribution, and also maximize marketing and also marketing to maximize profit, right? So, who can give me an idea or just sort of explain what qualitative methods they might employ? Or maybe I should rephrase it, right? So, for example, this company, they want to launch their product, right? And they're like, okay, Bunmi talked about heart of forecasting. So, what are the non-data things that we can do, right, to sort of make a better forecast? I'll give an instance. Market research, right? Speaking to experts, people who have been in the industry, right? If they're a very new smartphone company, you want to know how other people are doing it. Do your research. Market research is one of the arts, right? Who wants to give me any other one?
You can do a survey around the catchment area you want to launch.
Awesome. Anybody else want to try?
I think market strategy also will be very important.
Market strategy.
Can give the phone to a small group of your original audience to test. You can give the smartphone to a small group of your original audience, like a test set, to actually.
Okay, so launching to a smaller test. Okay. Now let's move to quantitative models, right? What quantitative approach can they take? Anybody wants to try? Okay.
The phone specifications, the smartphone specifications.
Specifications. Okay, I'm looking at specific methods, right? And also note that this is a new company. They don't have historical data. So you can't do time series analysis.
Maybe for that location they want to launch, they might need to know the number of people that maybe don't have phone before.
Okay? Someone is. What is it?
I was going to say total addressable market and the serviceable.
Okay. Anyone with a different.
In follow-up to what he said, what's their preference in that location?
Okay, so you can see we are gathering our data set already.
Just a follow-up to what he said as well, the purchasing power of the market.
Okay, adding to our data set. Yeah.
What is going to be the look of the smartphone, or how is it going to stand side by side the existing ones? That's to say, market research rather.
That's qualitative. Okay.
Okay, like more research about the competitors, like how they are making money with that product.
That's also another qualitative method. Anybody want to say any possible challenges they might have? Okay, I'm taking just two people.
Power supply for the people they are marketing to.
The challenge of technical know-how of what the other companies are doing.
That's true. I did specify the region. Okay. That's like really good. Really good. So now you can already begin to think, right? What qualitative methods you want to use, right? What quantitative methods? What kind of data set should you look for? And some of the challenges that you might face. Okay, next slide. As I wrap up, right? Don't forget, 99.9% actually doesn't equal to great forecasts. Forecasters are sometimes wrong, even experts, right? It's not their fault, really. And what I would say you should do is research, discuss, validate, right? And thank you. That's the end of my talk. Any questions?
Okay. Good afternoon. My name is Richard. I'm a data analyst. I just want to get your opinion about something. Do you think machine speed affects model accuracy?
I think the question would be, do you think the kind of machine affects model accuracy? Yes. The kind of machine, not necessarily the speed, right? Your model might be more accurate on GPU than on CPU. So it's not necessarily the speed, but the kind of machine. Okay.
Okay, so what do you think is the advantage of using GPU over CPU?
I think it depends on your data needs, right? If you have a larger data set, and you have money, you have computation, right? You can use a GPU. Right? And sometimes you might just need to use a CPU and figure out an efficient way of processing data, right? And that's another thing I figure out. You don't necessarily need to get big GPUs. You just need to figure out how to do distributed training, parallelize your computing, efficient data processing methods.
Okay, I want to ask, what if you use both your instinct, both your quantitative for analysis and your prediction is still wrong? That's using both the art and science and your prediction is still wrong. What will you do?
Uh, the chance of being wrong is lower than if you just depend on quantitative, right? I cannot say that 100% of the time you'll be accurate. But then there was this time where I was working and I saw the results. I just knew this cannot work. Sometimes maybe your gut tells you that this is not correct. So that's the art, right? Telling you that look for something else to do or look for a way to improve this. So when the art comes in, you're not you are most likely not to fail, right? Because, and again, you have stakeholders involved. You have people with knowledge involved. Even if you just focus on the art alone, you can get more accurate results than if you focus on just quantitative alone.
Money. My question is like the forecasting. I know, like it's based on numerical data, so I'm not sure. So I'm thinking like, can you use unstructured data like images and sound? And I'll give you an example, like to predict the degree of appreciation or depreciation. So let's say I buy like a shoe now from the shopping mall. So just by taking the image of the shoe, can I forecast the extent of degradation? Or a company wants to release a movie like Marvel. So is it possible for me to like, because probably it's a high tension movie. So can I predict what parts of the movie in which the tension in the room is going to high based on the sound of the audience? So can I use unstructured data for forecasting, like images, videos?
I think what you described is classification. It's not forecast. Forecasting is predicting what will happen based on what I already have. And it's mostly numerical. I've not seen images used for forecasting. It's like maybe you have trends of what has happened. And then what will happen maybe in the next 2 years, and all.
Okay, my question is, at times prediction, can also involve something that is novel, meaning that what you are trying to project, you find out it have not been handled. So, is there a standard way to measure the confidence in our forecasting? Like you are forecasting what you have not meddled into before. Is there a confidence interval that we were looking at and say this is the standard anytime someone is making a forecast to avoid the dance part of it where let's say forecasting in the science aspect could be taken as a theory. You've not verified it, you've not gone to the real world. So the real time matters at times when you approach things and find out it's novel. It's mainly effective forecasting, and the downside part of it usually occur. Is there a standard on how to forecast so that we always come out with a good result? Thank you.
You want me to tell you how to do magic? What I would say is forecasting again, right? You need to already have something on ground before you predict the future. You need to know at least the present, right? The past. So, novel. I think it would be better if you give me a scenario, right? So, because I can't really paint a picture of a novel idea, right? But there are different statistical metrics that you can use to measure. But again, your statistical metrics, your business idea, your business value, right? So that is like the overall metric, I think. Yeah. Thank you.